Hello, good morning. Good afternoon. Welcome to my channel. Today's question is find closest node to given two nodes. So, given is directed a graph of n nodes numbered from 0 to n minus 1, where each node has most one outgoing edge. The graph is represented with the given 0 waste index array edges of size n, indicating that there is a directed edge from node I to node edges of I. If there is no outgoing edge from I, then edges of I is equals to minus 1. So return you are given two integers node 1 and node 2. Also just given node 1 and node 2 given. So return the index of the node that can be reached from node 1 and node 2, such that the maximum between the distance from node 1 to that node and from node to that node is minimized. If there are multiple answers, return the node with the smallest index, and if no possible answer arose, return minus. So note that edges may contain cycles. The distance from node 0 to node 2 is 1, and the distance from 1 to node 2 is node 1 to node 2 is 1. So given here, just given and node 1 and node 2 are given. So we have to calculate, we have to return that can be reached, the text that can be reached from node 2 and node 0 and node 1. So node 2 we can reach from node 0 and 2 we can reach from node 1. So let it be 2. So given such that maximum between the distance from node 1 to that node and from node to that node is minimum. So that it should be the minimum distance. So minimum distance should be from the node 1 to from node, node 1 to that index and node 2 to that index. So if it is like 10 graph of 10 10 to 12, there is 10 to 12 between them, and it should be minimum, it should be 5 6, either, that's why it is minimum. So here we also given this construct the graph from here, and node 1 is 0, 2. So 0 and 2 is given. So distance from node 0 to node 2 is 2, and the distance from node 2 itself is 0. The maximum of these two distances is 2. It can be proven to that we cannot get a node with a smaller maximum distance than 2. So we return node 2. So this is this is the solution explanation of the problem, and this is the code here. So we will this is okay. We will this is the implementation function. Edges are given and start. So start 1, start 2 are also given. So we will get distance array. We need two distance array, and we will fill it -1, and uh, we will we will build the array, we will build this array. So from the given edges and from the distance 1, we will find, we will increment, we will distance, we will add the increment the distance from that array, and from the node 2 also we will do this one also. We can either create the construct the graph. Initially we construct the graph, and then we can do, and we can we can do with um, a disastrous algorithm, distances from the starting to the end, and this also can do. This approach is also fine. So this approach we will just focus on the distances arrays. We do not distances arrays, and like this we can calculate this one, and this less greater than 0, greater than 0. So it should be greater than 0. Then we will calculate the maximum of the either way, that one, and if it is less than 1, we will update this, and if it is less than 1, we will update this, and we will return the result one last. What is that last maximum value, maximum index value? We will return that index here. So this program, it's a graph and graph DFS BFS kind of program and submission. See, see for edges we got here node 0. Okay, output is also it is accepted executing correctly, and these two examples are so submit, submit the, yeah, these are 77 of these test cases are passed. So this is the explanation working of the this code. So if you have any doubts in this one, please comment it on video. And if you have any if any questions also, you can comment video. And like thanks for watching the channel, and subscribe, like and like the channel.